if I may. I want to talk about summertime overheating.
Yeah.
And we have some concern about the target of 10%. And there's been some talk that we have between us, and I think it may be also in Germany, about reducing the 10% because of the potential for wanting to safeguard for the future. That's easy.
I agree. We always recommend to have it by 5% or something because that's a better indoor climate. And the best advertisement for buildings like that is if you have a good indoor climate. So the 10%, that was in Germany the target from the government. This is what normal buildings normally can just afford. But in a passive house we can do better, and we always can come down to 5% in a climate like Britain or Germany. So why not do that? I completely agree.
Thank you. We've got a couple of issues about heat gains, and in particular we are concerned about heat gains from hot water, which aren't at present counted. That's our understanding in PHPP. And we're concerned about, again, the summer overheating, and would some of our hot water systems are not very efficient, and we do have some hearsay examples of hot water systems in low-energy houses causing a lot of thermal discomfort.
Yes, you are right. I think it's very important to have a look on efficiency of a domestic hot water system as well. And well, you have in the PHPP a calculation on that efficiency, but it's done in a little bit separate way because I didn't want to introduce that to reduce the heating demand.
Absolutely.
So because that will influence it in a completely wrong way. So I agree that we have to improve the efficiency of the domestic hot water systems. It's a very important thing, and I think there are lots of ideas how to do that. And it's important. It's in the PHPP, but it's separated from the building, which I think is the right way to do it, because you shouldn't heat a building by losses of a hot water system. It's a bad idea.
Absolutely. Finally, I just wanted to find the last of the technical questions. It's about this the gains, the 2.1 watts per square metre.
Yes.
From what we've seen and the figures of domestic electrical consumption in the UK, which are the figures which are used in our SAP calculation, this is a very, very small figure. And I'm interested in how that came about, and if it's in fact actually, is this a figure for the future, or can this be obtained now? Can we actually get down to appliances and lights? Can we get them down to 2.1 watts per square metre now with the current available technology appliances?
First of all, you'll have to see that this figure is the overall internal load and not the electricity. That's different because the electricity which is supplied to a house is used inside the house, but it's not completely available in the home. So let's have a look on the washing machine. The hot water will be completely pumped out of the system and it will in the drainage, and then it will be cooled by cold water again. So a washing machine is more a heat sink than a heat source. And so we have to analyze these things very, very closely. When there are some heat sinks, some other heat sinks as well, like domestic cold water, like evaporation and if you put all that together, you will see we've done that calculations and we have done that comparisons and measurements. In the very first passive house, we did a thorough analysis of all internal loads, and it turned out to be 1 watt per square meter.
Right.
Yeah. So doing that thoroughly, we have seen it's 1 watt. But now again, where the freezer was placed outside of a thermal shell, but that would change it to 1.3 or something like that. So I'm quite sure that the normal figures normally used quite in most countries are too high. If you really take into account what's really happening inside of a building, there are lots of processes which are not accounted for, which have a heat sink capacity. And so, well, of course, if there are very inefficient things in the building, like incandescent bulbs and like old fridges and things like that, the figure could be higher than 2.1. It could be 3 or something like that. But in almost all cases, it's not higher than that. And then, what is quite important, we have to design the buildings now so that they will work in future as well. So even if you have a incandescent bulb and a very low efficient refrigerator in the building now, you will exchange that in 10 years, in 15 years, and then it should still work. So we have to keep track of these things from the very beginning. So that's another reason why we are a little bit cautious with the internal loads. Not that I say it's not, but what you already talked is that measured results were already giving a hint that it might be even lower than what we take into account. We know that if you have not good appliances at the moment, it could also be somewhat higher, but I think that this value is quite in the right dimension.
Thank you, Wolfgang.